Have you ever wondered what would happen if you fell into a black hole? It's one of the most mysterious and terrifying objects in the universe. A place where gravity is so strong, not even light can escape. But black holes aren't just dangerous, they're essential to understanding our cosmos. What exactly are they? And why do they fascinate scientists and dreamers alike? Stick around, because we're about to dive into the heart of darkness. Black holes have captured the imagination of scientists, writers, and filmmakers for decades. From Interstellar to Star Trek, black holes are portrayed as gateways to other dimensions, or cosmic vacuum cleaners that devour everything in their path. But what are they really? In simple terms, a black hole is a region of space where the gravitational pull is so immense that nothing, not even light, can escape it. They form when massive stars collapse under their own gravity, creating an object so dense that space-time itself is warped. But the real story of black holes goes far beyond that simple explanation. Let's take a closer look at how these cosmic phenomena form, their key features, and the mysteries they still hold. So, how do black holes come into existence? It all starts with a star, specifically, a massive star. Stars are powered by nuclear fusion, burning hydrogen into helium in a delicate balance that counteracts the force of gravity. But eventually, stars run out of fuel. When a star at least 8 times the mass of our Sun burns through its fuel, it can no longer hold up against its own gravity. The star collapses, and if it's large enough, this collapse forms a black hole. Essentially, all the star's mass is packed into an incredibly small point, known as a singularity, surrounded by a boundary called the event horizon, the point of no return. Let's break down the parts of a black hole. The singularity. This is the heart of the black hole. It's a point where all the mass is concentrated, and the laws of physics, as we know them, break down. Imagine taking a mountain and compressing it into a tiny dot. Sounds impossible, but that's exactly what happens in a black hole. The event horizon. The surface of the black hole is called the event horizon. Once you cross this threshold, there's no turning back. Nothing, not light, not matter, can escape the gravitational grip of the black hole. For an outside observer, time appears to slow down near the event horizon, a strange effect predicted by Einstein's theory of general relativity. The accretion disk. This is the hot, swirling disk of gas and dust surrounding many black holes. As matter falls in, it heats up to millions of degrees, emitting X-rays and other radiation. This is how we detect black holes. Since we can't see them directly, black holes have been at the center of some of the biggest breakthroughs in science, but they also pose some of the biggest unanswered questions. The information paradox. What happens to information that falls into a black hole? According to quantum mechanics, information can't be destroyed. But in a black hole, it seems to disappear. This paradox has baffled scientists for decades, with famous physicist Stephen Hawking suggesting that information might escape through Hawking radiation, a faint glow theorized to come from black holes. But we still don't have a clear answer. Supermassive black holes. How did black holes millions or even billions of times the mass of our Sun form so quickly after the Big Bang? Supermassive black holes, like the one at the center of our galaxy, the Milky Way, remain a mystery. Did they start small and grow? Or did they form in a different way altogether? Wormholes. Black holes are sometimes theorized to be connected to another part of the universe through wormholes, a kind of cosmic shortcut. Could black holes be gateways to other universes? While it's a popular concept in science fiction, we don't have any evidence yet. In recent years, black hole research has made huge leaps. In 2019, the world saw the first ever image of a black hole, the supermassive black hole in the galaxy M87, captured by the Event Horizon Telescope. This was a monumental achievement, showing us that we can now observe these invisible giants. Gravitational waves. Another breakthrough discovery are ripples in spacetime caused by massive events, like black holes merging. In 2015, we detected gravitational waves for the first time, confirming yet another of Einstein's predictions and giving us a new way to study black holes. Black holes represent some of the most exciting and profound mysteries in the universe. As we continue to study them, who knows what new discoveries we'll make? Maybe black holes hold the key to understanding the very fabric of reality itself. If you enjoyed this deep dive into black holes, don't forget to like this video, subscribe for more cosmic explorations, and hit the bell icon so you never miss an update. What other space mysteries would you like us to unravel? Let us know in the comments below. Until next time, keep looking up.